Hello, I'm Susan Nash, AAPG, and welcome to our GEODE, Department of Energy funded workshop that is organized by AAPG. And our goal in this workshop, in this series of lectures, is to accelerate the development of geothermal by using oil and gas technologies, and also that may include repurposing oil and gas wells or using infrastructure. And I'm so thrilled to be able to introduce Patrick Ng of Shaleforce, who has been looking and digging deep into how AI can be used to accelerate the development of geothermal. So welcome, and I'd like to introduce you and welcome you to this webinar.
Well, thank you, Susan. And good afternoon, good morning, everyone, where you are. I'm Patrick Ng, Shaleforce. I started in R&D at Western Geophysical and had the opportunity to advancing the S-curves in 3D amplitude versus offset and later pre-stack depth imaging that really opened up the entire deep water Gulf of Mexico. More recently, the focus has been actually drilling for real oil and gas. Now, of course, I joined a boutique shop for raise capital and drill some wells in South Texas. But I really want to go back to the beginning as far as how we look at oil and gas is first found in the minds of men and women. Now, it's still pretty much the same when we go from fossil fuel maybe to geothermal, hydrogen minerals, because it's all subsurface. There are a lot of unknown and use geology to help untangle the puzzle. But engineering to extract those profitably and economically. So in that regard, my current interest is to learning with machine AI particular and beast machine learning alone. And together we can thrive. So let's see how it all works. Now, I believe we have learned a lot from yesterday and earlier today, the speakers, the technical aspects of geology, geoscience, and engineering of all the complexities that we have to anticipate and manage when we develop these geothermal reservoirs, the stratigraphy and subsurface characterizations. So for the next 30, 40 minutes, we focus is the time for actionable insights. By that, I mean the play fair way, how we look at maybe from a high level view, and then home in on a particular area of interest to determine the project economics and de-risk a prospect for drilling. And then at the end, it's really about execution. So what I also want to is to illustrate a suite of tools that help us to facilitate the formation of public-private partnership and accelerate geothermal development. Tying it all together, let's think, well, first the mindset. It's all about harnessing the heat beneath our feet. So you can click on that and go to the article referred to. But here I want to focus on Texas. In fact, Texas corridor from Rio Grande Valley through the Gulf Coast to Shreveport, Louisiana. Now, the business landscape, I think, offers favorable conditions. First is technology. Enhanced geothermal systems really benefit from the relentless focus on lowering the drilling and completion cost from the shale revolution. In a short, probably 8 years, we saw it came down in half of drilling completion. The second is proximity. Well, we have existing oil and gas infrastructure, so maybe it helps the thinking about the proximity to market, but at the same time, maybe there are opportunities for new drill as well as retrofit, meaning converting oil and gas well for geothermal purpose. And lastly, it's the business model. Google and Fervo and Meta and Sage Geosystems had demonstrated the use of power purchasing agreement. So it's commercial. But what we really want is to leverage on a commitment from the Department of Energy, allocating capital to technology transfer and accelerate that development of geothermal resources. All right, so let's go back to first thing. What is a play fairway? Well, here's an app you can play with, but after the presentation, we can also go live and check it out. So here, simply, we can have only a sample of wells, small percentage of the wells, but at least to show the possibility, the potential. So here we say we set a threshold 150 degrees Celsius, and then the depth. So we can see the trend here, what I mean, from Rio Grande Valley along the Gulf Coast to Shreveport, Louisiana. So this is kind of a, well, favorable geothermal area and opportunity for looking at both new drill and retrofit. But within that, we can certainly take a quick look. One of the things is around the top 10 county with most of these wells located. But really, what's important, understanding, just like in oil and gas exploration early on in the play, we really want to get a feel for what the distribution of the underlying opportunities would be. So in this case, the orange is the bottom hole temperature, and blue is the depth, but it's kind of scaled, divide by 50. So I can squeeze them both the same plot because of different range of numbers. But this is the important thing. Recognize it's not a simple normal distribution. You can see kind of like this and the depth. So when you start thinking about how to de-risk project, this is the kind of information you want to have upfront rather than after the fact. All right, let's think about risk assessment. We want to take a 360-degree view. Yesterday and earlier today, we learned about in subsurface, the geoscience, engineering, and sequence stratigraphy. Some of these are just snapshots that I kind of capture as the speakers went along. And then the surface aspect, the facilities, the binary power plant, organic Rankine cycle, the kind of fluids used, and then the offtake to customers. But I will focus particularly on a techno-economic analysis, you call it TEA. In particular, the two questions I like to address is first, is geothermal investable asset? Does it produce reasonable return and so forth? The underlying project economic modeling is using geofires, which I'll go into a little bit later. In the opportunity retrofit conversion is really about, well, what's the size opportunity, a number of wells maybe we can look at, right? Okay, so really, this is kind of a simple mapping of what I would consider a typical exploration workflow. And then for each one of these tasks, there's an app that go with it. So when I said a suite of tools, well, actually, they're a suite of apps. So for example, first, many of you, I'm sure, have used ChatGPT or something similar, and to interact, that's generative AI. And here we have trained a particular one focused on geothermal. So if you go to this particular link, you see a web app, and you can just enter like ChatGPT, ask about something about Texas, about geothermal opportunity and areas. So kick around some ideas. And maybe once you determine, hey, there's some interesting opportunities, then this next step is really to help us a simple way of quantifying, should we spend more time and effort? I call it gut check. If it doesn't really make sense, maybe you move on to another spot or something. So the focus is leverage on the National Renewable Energy Lab's GeoFires package. It's a very comprehensive economic project modeling for different kinds of configuration, like enhanced geothermal system, as well as doublets and other that is fit for the particular opportunities. Now, you can run it, but one of the things is that it's open source and it's got 90 parameters. So, but there's only one really high parameter that we would use early on to quantify and determine whether we want to spend more time and effort to investigate, is the geothermal gradient. Basically, it's the rate of change of temperature increase per kilometer. So the app trained on varying these different thermal gradients for a particular configuration, so that when you enter a number, you'll get the break-even cost. So we'll see how it works in a couple of seconds. And then as you get past this, you say, hey, I want now home in on an area. Then this is the map augmented platform that Shaleforce really think we're going to spend a lot of time and effort in making it work, and combining with the AI and moving towards more like ChatGPT, the generative AI approach. But for now, if you enter address or enter county information, it will come back with information about the economic viability of that. Okay, so now let's move on and see how each of that step works. So step number one, first play, explore ideas. So this is just a shot from the screen. You can ask a question, something like this, and it come back with maybe some suggestion, what some of these areas, and particularly with a little bit more information about the temperature and the depth. So again, it's kind of a little example, illustration of what quantitative retrieval augmented generation, generative AI can be used to help us to jumpstart our exploration effort. We get past that, we say, oh, based on the previous look, it's about 160 degree and 3 or 4 kilometers. So maybe a thermal gradient, well, put it in, let's say 38. This is the one that train on the NREL geophyres, but we trained a particular configuration, 2 injector, 2 producer pairs to a depth of 4 kilometers. So in this example, it tells us that, hey, the break-even electricity cost is 14.6 cents per kilowatt hour. And the break-even direct heat use, that is 5.66 million BTU. Now, the important thing is that you can think of this as like the natural gas price and for power. So if you think, hey, Henry Hub is about $3, well, looks like it's not very competitive. But I want to also say, hey, this is the levelized cost of energy, and which is over the life of the project. So if we're going to compare apple to apple, then it's not just what you pay if you're using natural gas. You want to also include what the cost of carbon capture would be. So based on current carbon credit, I think that translates into about around $4 and MCF. So if you say I pay $3 Henry Hub and plus that $4 and make it about $7. So for direct heat application, geothermal at this particular maybe location with 38 degrees Celsius per kilometer, it makes sense. But the other part is about the electricity. So if you are in California, they pay 20 cents kilowatt hour, great. But in other states like Texas, perhaps it's not quite. But again, you would have to take into account that down the road, the cost of carbon capture, right? So where this does not require any of that. All right, so now you get past those, but one of the things is also, we heard some of the comment earlier, when you talk about geothermal, it's, yes, you want to also consider the surface facility location. So what this does is that it lets you, please, in the map, we have a little guy here, you can drag that and get a street view, not just the economic, but also what the environment is when you are actually going to develop the project. So for example, this is the location that you can see. If you actually happen to be close to a well and the street map covers it, you can see, kind of get a feel for the conditions. Is it well maintained, or if it's not, then you want to be careful. So again, it really helped to do a quick due diligence for opportunity for retrofit of orphan wells. I would consider that as a zero emission due diligence because it eliminates the need to drive hours or hundreds of miles. I've done that really just to look at some previous existing wells, whether we go in the re-entry or so forth. So yeah, save time and money. Now, let's take a step back. I think on AI, 2 aspects. One is predictive. The predictive is very much basically machine learning. So like the techno-economic analysis, the T app that we talked about earlier, I enter 38 degrees Celsius per kilometer, it go through and come back with a response, right? Whatever the training was done behind is very straightforward. Now, what is interesting is the emerging use of AI, more generative AI, is that I can ask a question, and as you saw earlier, where would be the counties for a potential for geothermal development, it'll come back and give those response. Now, combine the two, moving forward to a map augmented platform, is really the single focus is to drive towards ability to define, de-risk and drill better wells so that we increase the probability of commercial success. All right, so that's, I call it hybrid because it really combines this let's say, in a particular area, do that and come back with a technical economic assessment. Right. First, let's think back of the advantage of getting into granularity, highly granular data. So for example, in the oil and gas in Texas, we have the monthly production report rolled up under a lease. So if a lease is one well, that's basically what the well performance. But some leases in West Texas, one single lease could have more than a couple of thousand wells. That is not trivial exercise. So instead of trying to do it manually every month, at Shaleforce, we have developed the auto machine learning process so that we allocate the lease production to individual wells. So again, it simplified the process. So for each one of those wells, we can quickly run using machine learning and do decline curve and then extract and predict what's the estimate ultimate recovery. But just for illustrating, granular data can open up other potential use. So for example, here we carry out a customized study for customer, let's say benchmark some operators back in 2022. Now what happened here is that horizontal axis is the cardinal number of wells. For each operator, let's say they go in and do 100 wells. So, we take the peak production from first well, add to the peak production from the second well. And so these you can think is like over time. And then these would be the cumulative peak production on consecutive well. A simple thing is further up on this quantile is better performer versus those down here. Now, so what's interesting is that after this, in the next 12 to 15 months, Centennial Resource and Colgate merged to become the Permian Resources. It's listed. And then Diamondback acquired Firebird. Now, Firebird at the time was private. And you can see Diamond and Firebird, and then Colgate and Centennial. Well, they're doing pretty well. They come together. They can even exploit the economy of scale. But one also notice here, no, it wasn't acquired. It just rebranded itself. And that's right here. Now, you can make with the interpretation, but eventually in 2024, in fact, ExxonMobil acquired Pioneer Resource. And in fact, they were pretty good as far as a 2022 snapshot you can see here. All right, so it really gives you a sense of that's very useful to have granular data to explore some other potential M&A opportunities. All right, so let's think about, with that granularity, how do we think about retrofit? Well, one simple metric we can use is, let's say, for example, you take a single well, you can do the decline curve, and then you would say, hey, based on that, whether you use machine learning like long short-term memory or ops, and you can extrapolate it out and say, hey, what's the estimated ultimate recovery? And then you take off from that, what's the cumulative production today? And then you have an idea what the residual would be. So that residual is what I would say maybe a measure of opportunity for converting the oil and gas wells to geothermal. All right. And because we have done the heavy lifting, auto machine learning, to go from a single lease aggregated report to individual well. So basically, it's just very much automated this whole procedure of using the residual as a measure for opportunity for retrofit in any area. All right, let's step back. Reservoir data analytics. One of the things is I actually recorded back in 2019 after AAPG workshop. I think I had a conversation with Professor Holbrook, and I said, "Hey, is it possible to use the EUR as a measure of the size of the chambers, whether it's geothermal reservoir or for energy storage?" So this is kind of just things that we have so we can display it. But what you see here is that the depth, temperature, and the size of the bubble is the EUR for oil in this case. Now, again, the important thing we want is to get a sense of the distribution. Don't mean just a number like average, but the spread of, like in this case, the bottom hole temperature or the depth, so that when we go in, we kind of see how much variability then we have to be thinking about. So maybe for the particular distribution, bottom hole temperature is more like A and B normal, not exactly a simple normal distribution. So keep that in mind. So again, we need to zoom in. But now let's step back. We are thinking, well, geothermal renaissance, we've been talking about it for quite a bit of time, but the opportunity really is to relate that to deep decarbonization of industries across the board. So for example, this referred to the chapter 2 of the Texas Geothermal Report came out early 2023. It illustrates a range of industry, which is actually all the way across from chemical, refineries, paper mills, and some making bearings and auto parts. And so you can think of all the way along here. And these are the different temperature range required for the processes. And certainly a lot of those are very favorable for direct application from geothermal. And then later, when I think, given this information, how we think about step out onto the shelf. All right. So first, think about using existing oil and gas wells, or just think about what the opportunities are, even just go in and further pursue oil and gas. So here again is a map augmented platform. You enter, let's say, Midland International Airport, Texas. It will come back with, say, well, within the 5-kilometer radius or 3 miles, all these wells, what is the P50 of the depth and the lateral length, and then the EUR of the wells. In fact, I also want to get a P90, just get an idea. So if you're down here, I mean, your wells hitting this, great, it's money making. And then as one of the additional thing, again, related to opportunity for retrofit or conversion is the half-life. So when we see wells that maybe they already in the 6, 7 months or 12 months, they kind of past prime. So that may be worth taking a closer look. But if you're down here in these kind of highly productive monster well, you know, you might have to wait a little bit. But the other thing is that really, you don't want to shut down a well and then try to go and do something, because usually, no, there are a lot of complexity. But what you want is, if you're thinking of an identified candidate for conversion, retrofit, you do some of the planning ahead before it get way past the prime, and so you're better off. All right, so this is up in the Permian. Now let's just check, just curiosity. We're down in Kansas City, south of San Antonio, in the Eagle Ford area, and so again, you see something like the P90, you get this, and the depth and the well, P50, the lateral, they're comparable. So again, you see this is a quick scan. So if you see a bunch of these makes interest, then of course you can go back and drill down further to these wells. So it's a quick time saving. Instead of spending weeks, and there's a few minutes we can interrogate an area and move around. All right, stepping out, just as Joe's presentation an hour earlier, the first location was near Galveston Bay, and here I just want to quick check Galveston County, and there were 4 calibrated well, and from them, you know, derive what the opportunity may be from a break even for if it's new geothermal development and direct heat. And for the second location, near Victoria, again, we get this just as a quick check. And so if it looks reasonable, we can do some more due diligence. But again, it sets the framework as to something, is it close enough, or can we look at it in a more detail and tweak it more? Okay. The other part is this allows us to quickly discern something is possible, potential, or really too far out to make sense. So we just move on and save a lot of time in terms of you know, going back and forth. And in fact, you can have a bunch of people looking at these together, and different idea can come up as well. So all that is great. The data we can use, but it comes back down to real intelligence. It's how we as professionals, geoscientists and engineers, work together to manage the energy transition. Well, let's just say from a geothermal perspective, what happened between now into 2035. If we're successful doing some of these along the Texas corridor, maybe still some oil and gas, certainly. Maybe some of those will be used for storage, pressurized fluid, and then the other, a new drill for geothermal development. So it's a combination of mix of them. And we can maybe do that by 2035, put geothermal thermal on the map. But there, start thinking about a portfolio. So just a recap so far. The suite of apps delivering actionable insights in minutes, not days. And the play fair way kind of ChatGPT approach. And the project economics, we use the techno-economic analysis built and trained on geofires. And then when we bring it together back to a map, because a lot of time we start early, ideas on a map, and then when we come to allocate capital and make final decision, we also refer to a map on drilling location and facilities. So that's a map augmented platform. And what we demonstrate also, while there are 3 apps, but really it kind of establishes execution workflow and how we can use it. We can iterate quickly, and really the goal is develop geothermal resources better, faster, and more at scale, so we can make the energy transition work. Capital is required in order to make it scale. We need private capital, and it might be a combination of public-private partnership. So what I say is, again, we come back to take lesson learned from shale revolution, de-risk what we learned. So 2016, we published a paper in the Oil and Gas Financial Journal. It's really highlight the misappraised risk would translate into mispriced assets. We might pay too much. So for example, this is using example in Eagle Ford. And this is the distribution of the initial production, and which is a proxy for a return of those wells. And you can see the different distribution you fit. If we just assume it's normal distribution, you use the average, which is about close to 800 perhaps for the initial production, and you use it to do your project economic, it looks really good. And whereas the P50, more like this here, is maybe just under 500. So, right off the bat, you might have too rosy a picture of about 20-some to 30%. So we see that in many different areas. Now, what that is, you set the expectation high, but then maybe went up under deliver. Well, so what's the big deal? Well, one of the things that interesting, 2020, this article talk about, wow, shale drillers destroy 500 billion of capital. Well, it's a little bit more for news consumption, but the fact is, with the $1.2 trillion or so that operators spend on drilling shales over a period of decade, then if you think about a 20-some, 30%, yeah, that's kind of like what it would be, but I'm not saying this really explains everything in there, but I think what it means is that a lot of time people rush and then they overpay for what they get, the asset. So impair the return. So since we talk about portfolio, I just want to bring up a whole different app just for illustration. And so we're using 5 index stocks. This is utility. This is liquefied natural gas. This is natural gas and oil. Well, here is Tesla, but is maybe a proxy for the future electrification of transportation. So they all have different ups and downs in that volatility. So the utility has less volatility in all the other 4. Now, in a portfolio sense, what we want to look at is that if we have this portfolio kind of different aspects for energy transition, how does it perform? Well, this is a little summary. What we want to is compare if I substitute the utility by geothermal, which using simulation, what would be the impact? So let's first take a look at our reference. So this portfolio, the return based on objective. Now, what it means is if I want to sleep like a baby at night, I want low volatility. Well, in that case, the combination may be higher weighting on about 70% on the utility and much less on natural gas, because you can see it bubbles up and down a lot more. Or I have more risk appetite. I want the highest risk-adjusted return, which is really just the return divided by the volatility. So I might have a different take. Maybe I really don't put in the utility, but beef up on the Tesla. Now, it's just for comparison. So we say, what if I substitute this by geothermal, which has no correlation, has zero correlation in oil and gas prices. So in a portfolio sense, in these portfolio theory, that's a great opportunity to maybe generate a lower volatility or portfolio overall, but maybe as such boost the risk-adjusted return. And that's exactly what it bears out. So if we model the geothermal, and we might find out that for the risk-adjusted return, we actually go down in volatility, but increase in the Sharpe ratio, which is a measure of the risk-adjusted return. So by putting a little bit more into the geothermal. So again, first of all, it speaks to the number one question I asked earlier: is geothermal an investable asset? And I think once we make it work, make it commercial, the answer is yes, it makes sense as part of a diversified transition portfolio, energy transition portfolio. All right. Now let's think about how we accelerate the whole development of geothermal resources. It's interesting, Ford GT40, they were never in Le Mans, and Ferrari was the champion. But then what's interesting, a fellow came in, and Shelby, and they say, hey, you can't win a race by committee. So they let him go off and build this supercar. And in fact, it won 4 in a row. It's a 24 hours, it's both speed and endurance. So I would just say right now, it's interesting to see there are these front runners in the startups, in fertile stage, Evor, and also some way out there, Crazy Energy, that vaporize rock, and so it doesn't even use fluid for drilling. So, and then the retrofit, I guess we had to play a gradient, Greenfire, Forterra, and running Foxes, as earlier that Stephen talked about. So again, the race is on, and we see how all this play out. But one thing is, again, I step back to here and say, what we built is a suite of apps that match the workflow so that we can create more opportunity for people to use this map augmented platform to de-risk the opportunity and maybe get commercial success. Now, this same framework applies geothermal, oil and gas, in future, geologic hydrogen, minerals, and something about gravity-driven or pressurized fluid for energy storage. So again, it makes it possible to expand beyond that by using API calls to other players that want to join us and be able to incorporate their technology and protect their intellectual property. So together, we can deliver geothermal renaissance by 2030. Yes, I would like to suggest AAPG, Shaleforce, and working together, we could provide an ecosystem with a suite of apps to continue to make that faster, more. Now, sometimes the same plot, different technology, from indirect hit to precision bombing, but it's about flying the field. This is going into a trend, so the story plot is the same. So what we want to is build on the success of Shale Revolution, the relentless focus on lowering drilling completion costs, and using these AI in a way that encourage the meeting of minds from different domains, different expertise, even from commercial perspective, come together and develop, I call the energy renaissance, awesome threesome triple play, oil and gas, geothermal to geologic hydrogen. So drill, baby, drill, all subsurface energy, and we make transition happen 2050. Well, delivering managed predictable energy transition. That's really my my goal. And using this AI app development with help from Google, together with AAPG and GEODE, we can thrive. So to say to the fans of geothermal and to you all, thank you. Susan,
That's
now return back
wonderful.
to you.
Yes, I just love it. And thank you so much for saying together with APG and GEODE, we thrive. Totally agree with that. And I just wanted to know a little bit about Shaleforce because it seems like it's so useful. Is it easy to access?
Yes, in fact, I would say right now, so this is the one that I say map augmented platform, right? And
Mm-hmm.
so let's say we say Galveston County, Texas. And as we said before, the if I enter county, it knows, hey, you're interested in just in general, this area within the 5 kilometer, what the opportunity would be from an economic standpoint. So we come back with this. But let's say if I enter a different, like Midland
Yeah, let's look at Midland.
Airport. Well, in fact,
Okay,
I enter an address, all right?
okay.
So when I enter an address, it actually, what it does is just come back and tell me, hey, how many calibrated wells are there, right? Because
Oh, wow.
some of these area had very few wells. So,
Mm-hmm.
so again, you think of it now, I only use calibrated geothermal wells. But remember, if I use oil and gas wells in the back, I might have, 452 wells around that Midland Airport. So
Right, right.
yeah, so again, this is very flexible, but if I start mixing the oil and gas, and I get overwhelmed. So right now
Right.
it really but this is the same interface whether you're using it for ChatGPT like geothermal GPT or
Mm-hmm.
the techno-economic analysis is the same. It's just a simple box. I enter something. So what I really want to present is that it's just an infrastructure for bringing different ideas and different people with different expertise and start thinking about linking up their data with this same interface to work across.
I think that this is exactly fitting a need or meeting a need that it was that people have, and then it's overcoming a typical obstacle or barrier.
Right. So this is the other one I said earlier that I use
Mm-hmm.
it to like interact with customers. Say, hey, what do we really want to do? This is a quick like a drawing board, but instead of drawing board, a set of display. Just kind of, hey, for example, I have this is only like I forgot it's like a few percent of all the wells, but this is like in the Texas oil and gas wells. So if I
Mm-hmm.
start saying I want to look at because I'm not interested in some of the shallow wells, but for geothermal, get enough heat. Like I'm down here 167. I want to go down to say around 10,000 feet
Right,
where the
right.
wells are. Well,
Okay.
it shows, right?
Oh my
So,
goodness.
right. So you can get a sense. That's why I said, if I
I
go
love
to
this.
the geothermal GPT kind of like, oh, along Texas Gulf
Yeah.
Coast, your opportunity, I can actually go into the well database and just create a quick look at
Mm-hmm.
how, what's the extent. So it just use some counties because again, it's hard to talk about location, latitude, longitude, but we talk about counties. At least people can kind of visualize where they are. Galveston County, Jackson County, and so forth. So now here's the
Exactly.
other one. When I talk about the gas well, this gas well is bigger hole size usually. So this is a EUR of gas, and so there's some wells with well, again, go back to the chamber size. The bigger the
Mm-hmm.
EUR, the bigger the chamber. And so again, you can see maybe these are the wells that you want to take a look at first, so forth. So for retrofit, it maybe accelerate the process of filtering out hundreds, thousands of wells into a field that you can, put your pin on and do some more work. But the more
Well,
important
yeah.
thing is that let's say I have, this is just like if I have opportunity to look at a few counties, well, what
Mm-hmm.
would they be distribution wise? Again, it's just another step to home in and so forth. But this is the part that I think is really important is to understand if I have looks like a two peaks and so I don't want to use average. See, that's why the other thing is
Mm-hmm.
quickly I can understand, I can go back and zoom in on this, whether it's based on geology or spatial location, right?
Mm-hmm.
The important thing is if you start mixing these two, just get an average. I think as I mentioned that in the 2016 publication, misappraised risk translate into mispriced. But what's worse, if you raise capital, you set up a higher expectation because you use the average. And then when you underperform very quickly, people can write out whatever, oh, this idea doesn't work. But it really is not because of the idea did not work. It's just that we did not do the due diligence to de-risk the project sufficiently.
Right, right. That makes total sense.
That's really what I hope is by doing this, we combine something simple interface. There's no, I would say the probably is no learning. It's just learn how to type. And I can then do a lot of these from high level, the geothermal GPT to a technical economic analysis and spend a lot of time here to refine and pick different location, right?
That totally makes sense.
Yeah.
And earlier when you said it's all about location, I mean, by using the geospatial approach, then you can narrow down and say, okay, well, you want to do it in an area that, say, for example, needs energy, but it's far away from the grid. But and so it's good for like community development as well as anything else.
Well, Susan, you used the word community. I know you gave a story about in Oklahoma, the coming together with the tribal
Yes.
nation. But let's just think like usually if we go overseas exploration, what do we have to do? We have to engage community. We sometimes, not every place, but I know when one of my friends in Kenya, I mean, you need to start talking about community, building school, not just explain what you do. You do other
Right.
things.
Oh my goodness,
Now,
yes.
think of one thing. The thing I like about geothermal is it's almost remind me of the early days of, well, not early days, but early back in the 80s when geophysical exploration was very active in the lower 48. And we have seismic crews or go, I mean, I go down to South Texas. I mean, the crews live locally, but they go and drive out there, do the survey, and go back home. But it sustained a lot of communities, economic as well as social, development. But many of the places where there's bust and boom, but if you think of geothermal, here's the same effect. Once you put your geothermal power plant or whatever the project, it needs maintenance. It's not high maintenance cost, but it does require maintenance. But also, when you start looking at these costs, you say, well, levelized cost of energy, LCOE. Okay. Private capital might say, Susan, what's the payback? Now, if you talk about oil and gas, like some of those monster wells we talk about, well, payback could be in months or, small number of years.
So it might be months, but then we
Geothermal
also
might be a
remember
decade.
that, but they also decline. A lot of the high producers in the shale wells. So, whereas the geothermal, hopefully, will not deplete or decline.
Well, actually, that's why the Fervo pilot is so important. But some of these model simulation, it's got decline, but it's very tiny. You talk about half-life, this half-life can be over a decade. Right? So this is very different. Now, so let's just say if you're in a community subject to whatever the hurricanes, the kind of climate-related issues, if you have geothermal, maybe you have less worry of that, but also in terms of managing the fluctuation of gas, oil, and gas prices. Geothermal, this is the levelized cost of energy. This is predictable. And so for community that wants sustainable and predictable, resilient energy source, there's a value to that, plus the social economic impact. So that's the kind of thing. It's not just quantified by number, but I think that's why I want to make it so that a landman or a city manager can look at these, come to my site, or with the appropriate information, and even geologists, some of them put projects together. They live in a community. They know what makes sense. And then when people look at these, explore from different angles, meeting of minds, they come up with better solution.
That's really smart. I love it. Well, thank you, Patrick. I really appreciate this, and I'm glad that you have your information available too, if people want to get in touch with you. And you might go to the slide that has your information, Shaleforce. And your email is png at shaleforce.com, which is great. There we go.
Yes. And we love to work across disciplines and form new partnerships. Thank you, Susan.
I love it. Well, thank you.
Pleasure.
And to everyone, you'll be receiving an email with link to the recording. So look forward to ongoing communications.
Take care.